Hey everybody, so we're going to go ahead and start with the Sun-Earth Relationship Lab. And what I'm looking at is actually, it's called page 50. I know there's a 50 on the bottom, that the pages may not necessarily line up per se. But just know that that's this page, as you see here, what we're looking for is the declination, the sun declination, which we know is the same as the zenith or the subsolar point. Okay, that's the most vertical direct rays of sun on the Earth, that location. And then we're also going to find the latitude of the tangent rays, which are the rays to the north and south. Essentially, when the sun the rays are virtually perpendicular to the Earth, what latitude that actually is. So to do this, we follow the instructions. We say, let's refer to the analemma, which is this thing. Okay, so you got to have this handy with you. And in the following column, fill in the declination of the sun and the latitude of the given dates. If the declination falls between two latitudes, take the middle up value 1/2 degree. Okay, so that means that if we're looking at this and say that the value falls somewhere, I know that these are very small lines, but if the value falls somewhere, like if we have 18, 19, and the value falls somewhere in there, just round to the larger number, in this case being 19, or if it was in the northern hemisphere, you see what I'm saying? So don't be, if you look on the quiz and the answers aren't exact what you got, if they're off by 1/2 degree or something like that, just know that I realize everyone's going to have slightly different interpretation when you're looking at this, and we all have differences how our eyes are going to be able to see these little tiny things. So that's okay. I just want you to do your best here. Make sure you specify north or south. That's important. And show your work. Again, this is just for the practice on the quiz. There's no showing of work. But let's go ahead and start, and we'll find the date here, November 22. Okay, November 22. First, we got to find the declination. So how this works is on the dates are kind of in this figure 8 here. Okay, in this figure 8. And at the top, we see this is the summertime, and at the bottom, we have in the northern hemisphere the winter time. Okay, also related to the tropics of Capricorn, Cancer. Now that you've seen the lecture, hopefully you have a little bit better understanding of how that all works. Equator being here, okay, so that's your equinox, and you've got the times right between March and September, fall and spring equinoxes. And what we're looking for, let's go back, it said November 22nd, okay, November 22nd. So what we're looking for is, let's look at this chart, and let's find November, which is down here. Okay, so let me move this up a little bit so you guys can see. Now I'm gonna scroll through, and how this works is you go follow kind of the order as they would in a calendar year. So October, November, in terms of direction, October, November, December, January, February, like this. So I guess you could say it is, well, from left to right, and then, yeah. Anyways, we're looking for November 22nd. So if I find the 10th, okay, here's the 10th, here's the 15th, here's the 20th, here's the 25th. So I know that my target is somewhere here. Okay, I'm just gonna make a little mark there. I know that's really hard to see, but here, let me try to show you that better. Okay, there's my little mark. So I know that that's November 22nd. Again, I'm trying to be as approximate as I can, okay? Now, as I see November 22nd as my mark, okay, here, what I'm gonna do is I'm gonna just scroll over to the left side, the y-axis, and I'm looking for how many degrees where this kind of correlates to. So I know that this line is 20, and I know that this line right below it is 21 because this is 22. So I'm kind of in between the 20 and the 21, right? 20 and a half, we'll call it. And I just told you guys to round up, so I'm gonna actually put this at 21. I'm just gonna write it here. And so 21 degrees would go on this line here. 21 21 degrees. Now, the thing that I want to make sure you guys put in here is whether this is the southern hemisphere or the northern hemisphere. Okay, so anything, as you're looking at this graph, anytime your mark lands above the equator, okay, to the top of the equator, that's the north. Anytime it lands to the bottom portion of the equator, that's the south. So in this case, this would be 21 degrees south latitude. Okay, so that's the answer. Now, the latitude of the tangent rays, this is pretty straightforward. We take 90 degrees, and forgive me, I have another paper here I'm looking at that you can't see, but we take 90 degrees, and we figure out 90 minus whatever our declination is. So in this case, 90 minus 21 equals, what would that be? 69, correct? Yeah, 69 degrees. Okay, 69 degrees. So that means that our tangent rays are 69 degrees, 69 degrees north and 69 degrees south. These two values should always be the same, except one's north and one's south, okay? In the grand scheme, you're working with 180 degrees because that would be half of a circle, as I show you like here, okay? So if you look at the Earth this way, notice that it's like a half of a circle, okay? And where the illumination from the sun is gonna be. So those tangent rays, that's what we're looking for. The zenith minus 90 is gonna equal one tangent ray, and as in terms of a value, and then we know that north and south are going to be equal, and the two should add up then to make that all work out. Okay, so that's the end of that. Thank you. I just want to be clear. I think I said something and didn't actually clarify. In this case, like for example, 69 in the north plus 21 is going to equal 90, okay? Then 69 in the south plus 21 is going to equal 90. 90 plus 90 equals 180. That's where we end up with the value, the 180 of the circle of illumination, like that. Okay?